So now let's do some experiments by using these hoop gliders. I made those hoop gliders last night by using like paper and also Kapton tape and two different sizes. And let's compare. I mean the behavior of these hoop gliders between the ground and also on orbit. Unfortunately, I cannot do that on the ground since I'm in ISS right now. So I'm gonna do this experiment on orbit with zero gravity. So after watching this video, please make these kind of hoop gliders and do this same experiments on the ground, and please compare the result. That's gonna be really interesting. Okay, so let's do that. I'm gonna slow this hoop glider, bigger one, and big loop first, like this way. Please check it out, what will happen. See that? Yeah, soon go upward and hit the loop. On the ground, of course, we have gravity, so this one has a lift, so go up, but on the ground, we have gravity, so initially just fly like this way because gravity and also lift almost equal, and eventually this glider lose velocity, then like a lift decrease and hit the ground. But on orbit we don't have any like gravity, so only lift, so that's why this glider goes upwards. Once more. Yeah, interesting, right? So let's try another way. So first time I did like a big loop first. So next time let's try like a little loop forward. I don't know what will happen actually, but let's try. Like this way. Oh, interesting. It's almost flew straight. That means I'm guessing that on the ground, this maybe go downward because, yeah, we don't have any gravity and go straight ahead. That means if we have gravity, it goes down, right? So please compare. That's really actually interesting. Try it once more. Yeah, interesting, right? So next, let's try this small loop glider. What do you think? What will happen? First, we're gonna throw like a little bit bigger loop forward, like this way. See that? Because of this small loop, actually initially I anticipated that this small loop has little lift, I mean less lift. So this one a little bit go farther and like a shallow loop actually, I thought, but actually this one is moved really quickly. Try once more. Oh, actually we didn't try this like a small loop first, right? So let's try that as well. It was interesting. Yeah, almost straight, but a little bit higher it flew. maybe because of mass, actually. This one has a more lift, but also has a mass, so it's really hard to move. That's why maybe this one is lighter, so maybe it moved quickly. I mean, loop was a little bit shallower. I mean, deeper radius. So let's compare by flying both in the same time. Is that okay? Like that. Oh, I understand. Now I can see that. Actually, as I expected, this big loop has more lift, so that's why like a loop radius. This curve radius is smaller, go up higher, faster, and this one, small one, has less lift, so like a curvature was, I mean, a little bit shallower. See that? I'm gonna try it once more. Okay? So let's try. Smaller loop first, and those two in the same time. See that? Almost straight. That was actually really interesting for me as well. Like perfect balance of lift and also center of gravity. Lift means those two loops, and also center of gravity made this one who really straight on orbit. But on the ground, please compare that result. Probably, I'm guessing that that's gonna go down actually, hit the ground really soon. Hopefully, this experiment also really interesting for you. Okay, so let's see. Let's watch this experiment from the different angle. So I'm gonna slow far from the camera and see what will happen. So initially, like a big hoop glider with big loop first, forward. Yeah, really quickly hit the ceiling. And small loop glider with a little bit bigger loop forward. Okay. Yeah. Also hitting the roof, but the curvature, turn radius is a little bit, shallower. Okay. Radius was bigger. So let's slow, bigger loop, bigger hooped glider with small loop forward. Yeah, almost straight, but still going up a little bit. And small hoop glider and smallest loop forward. Okay. Yeah, still go a little bit higher, but almost straight. Okay.